All right, we're going to do just some really quick notes on 5.9. It's our last section of chapter 9. It's all graphing calculator, so I'm going to kind of remind you of some things and how you do things in the graphing calculator. So we have already talked when we looked at scatter plots. When we did scatter plots, we could look at it and tell that something was linear. We could look at it and tell if something was quadratic. We could look at it and tell if something was cubic. And we looked at those and I showed you how to find the function in the graphing calculator. So we're going to add a couple more things to that. If you're looking at a scatter plot and you get this kind of curve, then that's going to be exponential. Things are growing exponentially, where where A is positive and where B is greater than 1. In this case, your B, which is your base, remember, is like a fraction, like 1/2. So, but your A is still positive. So it looks something like that. Logarithmic. So remember, for the exponential, we talk about the fact that the x-axis is the asymptote. So you can see for each one of these, this is increasing, this is decreasing, but the x-axis is going to be your asymptote. Whereas if you're talking about a logarithmic, it means, remember, they're inverses of one another. The y-axis is going to be the asymptote. So you can see this guy is going up this way. So that is a logarithmic function. You can see this guy's kind of coming down this way. That is also a logarithmic function. And then the last type of function we talked about was the logistic. And remember, that was this equation right here. You can see, let me zoom in a little bit. And remember, we talked about the fact that in a logistic function, it has a point of inflection. Right here would be a point of inflection where it changes from concave down to concave up. Okay, so your graphing calculator would do all of these. So if we look at our first example, it says the data in the table shows the closing price of Harley-Davidson stock from the years 1987 to 2000. Then it says, using a grapher, draw a scatter plot with a year as the independent variable. So you can see in the chart, your year is your x's, and they're starting with x equal 1 for 87, and then your closing price is your y's. So I've actually already put them into my calculator, but let me just quick remind you of how to get there. So remember to put data in. You're going to go stat. That's the stat. And then you'll go edit. And again, I've already put mine there, but you would just literally put in your values from 1 to 14. And then you're going to put in your y values or your independent values in for your list 2. So why don't you pause it right now, go ahead and make those 2 lists. Okay, so now that we have our list, let's go ahead and let's quit out of that. Now, since we're doing a scatter plot, let's look at our window. So notice my window, I have that my x min is 0. And my x max, well, the biggest number I plugged in is 14, so I just made it 15. My y min was 0, and our biggest y is almost 40, so I just made mine 42. So now let me remind you about how to get to the scatter plot. So remember, you do second y equals, which is your stat plot. You arrow down to number 1. You turn it on. So make sure that you go to on and press enter. And then you pick the type of plot. Since all we've done is scatter plots, as you probably already have that in there. And then you just choose your mark. And now you can go ahead and you can graph it. And that's what your graph, your scatter plot, looks like. So I think you can see that this is fairly exponential. I know right here it could look like it might be some logistic, but if you notice in B, it says use the grapher to build an exponential function. So they're telling us that this is close to exponential. So that's what we're going to do. So let me quick remind you of how to do that. So if I do second quit to get out of that, remember to get the function, you go to, once again, your stat button. You go over to calc, and we did linear, we did quadratic, we did cubic, but now we're going down to exponential, so it's right there. Press enter, and then press enter again. So it shows you here, this is the form, it's y equals a times b to the x power, and they tell you your a and your b. And remember, we talked about the fact that the closer your r is to 1, that's a good thing. So you can see that this is like 0.99. This is darn close to 1. So the function that we're about to come up with, or that we've actually already come up with, is a really good representation of what that data looks like. So if we just go ahead and we put that into our function, so again, it's y equals ab to the x. And then if we go ahead, it would be y is equal to, and our a is 0.3945 times our b is 1.40, I don't know, let's go 28, and it's to the x power. So there's our function. Then the last thing it asks you to do is graph the exponential function that we found on the scatter diagram. So you're going to go to your y equals, and you're going to plug it in. So y is equal to, and you're going to plug in 0.3945, and then times 1.4028 to the x power. And then if we just press graph, you can see that it is graphing that function, and it's a pretty good representation of what that all of the data in the scatter plot looks like. So there you go. That's all you needed to do for 5.9.